Hello, my name is Benedikt Wad and I am a professor in food chemistry and exposome research at the Faculty of Chemistry. My research focuses on the development of new analytical methods for advanced exposure assessment of toxic food and environmental chemicals and their combined impact on human health and disease.
Hi, my name is Leanne Daly, and I am a professor in pharmaceutical sciences at the University of Vienna. My research focuses on how drugs are applied to and processed within the body. Since many drugs have similar effects to environmental chemicals, some of my research has expanded in recent years to include the health impacts of chemical pollutants in the environment. Hey, Benedikt, I was recently in the waiting room waiting for a doctor's appointment, and I read a magazine article about these forever chemicals and heavy metals in drinking water, as well as mycotoxins in tomato sauce and their potential harmful effects on the body. And I thought about your research on the exposome, and I was wondering if you could tell me a bit about it.
Well, these chemicals are gaining a lot of press coverage these days. Mycotoxins, for example, are poisonous substances that are produced by fungi, by molds, that can be found in different types of crops in varying amounts, including tomatoes and grains. Although mycotoxins, or PFAS, the so-called forever chemicals, are really important areas of research right now, they are only a very small part of the toxic chemicals we are overall exposed to in our daily lives. So exposome research is where we try to measure all of the exposures of a person in their lifetime and how those exposures relate to health. So Leanne, do you have any idea how many different chemicals you have been exposed to just today?
Actually, I don't know. But Benedikt, do you know?
Well, the answer is no one really knows, but it's likely in the range of 10,000 to 100,000 different chemicals. We know more than 100 million different chemical structures from literature and databases, but of course we are not exposed to all of them on a daily basis. And those that we are facing are actually not all bad for our human health. There are many beneficial exposures as well.
Okay, but wait a minute. Didn't Paracelsus say that it's the dose that makes the poison? So for a lot of these chemicals, if the exposure levels aren't high, will they even be poisonous?
Well, Paracelsus, of course, was right, at least partially right, but it's not only the dose that makes the poison, it's also the combination of harmful chemicals and the timing when you're facing the exposure that makes the poison. So we do not only identify which chemicals we are exposed to, but also how much we are exposed to on a daily basis. So how do we do this? We can use an analytical technique called mass spectrometry to identify sources of these chemicals in our food or in the environment, especially where they occur at higher concentrations. This could be the tomatoes or cereals for things like mycotoxins or pesticides. And it could be contaminated drinking water for the PFAS chemicals or heavy metals.
Okay, so it is very important to understand the sources of where these contaminants are found and how much is in it.
Right. And it even gets better. Our modern instruments are so sensitive that we have also developed methods in our lab to detect up to hundreds of these chemicals in the human body together in less than half an hour. And this is important when trying to understand how this crude cocktail of hundreds or maybe thousands of chemical exposures is impacting our health in the long term. Let me give you some examples. We already know that aflatoxins, which are mycotoxins, can cause liver cancer. The PFAS chemicals can impact immune responses, and endocrine disrupting chemicals can impact our hormonal balance and influence puberty. What we do not know yet is how all these chemicals, plus the chemicals we maybe don't even know today, impact our health together, for good or for bad. And many researchers believe that some chemical exposures together with our lifestyle choices can be linked to a large share of the chronic diseases that are troubling our aging society. And that includes many cancers, Alzheimer's or Parkinson's disease, and many others. This new concept is called the exposome, and it aims to investigate exposures in our food, in the environment, and most importantly, in our body holistically, to find out which exposures really matter and which should be reduced or even regulated to protect us. So Leanne, you know a lot about how to regulate drugs and chemicals. Can you walk us through this process?
Sure, no problem. So in a simplified scenario, we need 3 research teams working together on a known harmful agent. Your team, Benedict, provides the exposure characterization, where you determine how much of the chemical is exposed to humans and from which sources. My team would conduct what is called a hazard characterization. This involves using different types of lab tests to determine the lowest dose of a chemical that does not cause harm to the body. Many chemicals show what we call a dose-response profile. This has a curve shape. At low concentrations, the chemical has no toxic effect. But as the exposure dose increases, the number of people experiencing a toxic response to the chemical will also increase until a concentration is reached where everyone would be affected. Now, the important concentration for hazard characterization is the no observed adverse effect level, or NOEL value.
Now, who are we missing?
So the final team members are our colleagues who perform a risk characterization. They use mathematical models to estimate how severe the harm could be and how likely it is to occur, not only in a single person, but across whole populations. The risk characterization helps us to determine what are called uncertainty factors, which tell us how the exposure might vary among different populations. Let me give you an example. People in Italy might eat more tomatoes than people in Norway. So the risk of mycotoxin poisoning might be higher in Italy than in Norway. The uncertainty factor helps us set limits that protect everyone, regardless of where they live.
Okay, we have exposure, we have response levels, we have uncertainty. So how does this all relate to having a maximum permitted level that can help protect us consumers?
Okay, so to decide on a safe level, we take the no observed adverse effect level, or NOEL, and divide it by a safety factor, which is based on uncertainty. A very commonly used safety margin is 100. And this means actually that the NOEL value is divided by 100, or it's 100 times lower, just to make sure that even people who are exposed to different amounts of the toxic chemical are still not harmed by their exposure to the chemical. But I have to ask you, we currently usually set limits for a single chemical at a time. Now, based on your research, do you think this is a good approach?
Well, I would say it is the best approach we have to date. And while there's a lot of research going on, and some chemicals are intended to be regulated as groups, our knowledge on chemical interactions in the body is still very limited. And therefore, we need new technological tools using non-targeted mass spectrometry and advanced human biomonitoring, where we do multi-chemical exposure assessment in our human blood or in the urine. And in a second step, we then need to properly implement that in new ways in evaluating risk.
This information can be very useful for improving our computational toxicology models, which use computer models to predict the effects of chemicals, and especially chemical mixtures, on effects in the body. But I would like to ask you a final question, Benedict. How confident can consumers be about their choices of food or consumer products at the moment?
Well, due to advances in science and regulatory policies in the European Union, our food is the safest it ever has been in history. So even though we have been speaking a lot about harmful chemicals, It's important to put the risk into perspective and not cause any unnecessary worry in the public. This is where the new holistic concept of the exposome can be of great help to better understand the context between chemical pollution and public health. And actually, this is great news because the large impact of environmental factors on chronic disease means that we can actively do something. We are no victims of our genes, of our genome, but we can actively participate and make better informed lifestyle and consumer choices.
I very much agree. If you would like to hear more about this topic, we have provided a list of reading materials and links to informative videos in the course material. Thank you for listening.
Thank you for listening. And thank you, Leanne, for doing this video together.
Thanks for the great conversation, Benedikt.
Thank you.